Yeah. Alright, cool. So, last class we were looking at vectors. Welcome in, everyone. Hope everybody's doing well. Hope you're driving safe in the rain and everything. Last time we were talking about vectors, which is basically breaking things down into components, learning about their x and y values, and of course vectors is magnitude and direction. So we can know exactly where the force is coming from and the angle that they are forced at. So we didn't look at this little maze game. This is one of their simulations. It's kind of, I don't know, it's kind of weird. Like, if I drag it, the goal is to get this into this, the way that they have it. There's a way that you, it's kind of weird. Of course, this would more so be like position, you know, boom, and then I'm there. But then, if we're looking at the velocity, rather than me just controlling the position, then my velocity is going and it's going by itself, and then I gotta, you know, change the velocity like that. And then, you know, if velocity doesn't have, if an object is at motion, then it's gonna remain at motion until another force is acted upon it. So that's kind of what this is explaining. So we'll see that during Newton's laws. So that's velocity, and then here's acceleration. If I'm accelerating, and then to slow it down, I gotta go the opposite direction to decelerate it. But then it gets kind of difficult because it's gotta be, all right, so here's acceleration, start game, acceleration. So and then I gotta move it, but then I gotta decelerate. You see how it doesn't. See, that's one way you can kind of see how like acceleration works. It's like, well, of course it would be on a straight line if you're in a car or something. Of course it would be like a straight line. It would be like accelerating, decelerating, and won't go as wacky. But anyway, it was just a little thing that they have in the textbook. And then they have this one, you know, level 1, level 2. So and then you got to try to bring it through. So, you know, you can have fun with physics. Alright, so boom. See, that one's called certain death. That one's pretty difficult. Especially when you're trying to do acceleration. Super hard to get the right acceleration. You know, it's very difficult. Alright. So, just a little thing that they included. Learning about position, velocity, and acceleration. Alright. So, and then we're looking at vector addition and subtraction using the analytical methods. Understand the rules of vector addition and subtraction using analytical methods. You apply analytical methods to determine vertical and horizontal component vectors. Apply analytical methods to determine the magnitude and direction of a resultant vector. So we talked a little bit about that, talking about how we used our ruler and protractor. Hey, great day. Welcome in. So of course we remember components from last class, our vectors and whatnot, breaking them down, x and then y, so that we can have our resultant. And we talked about the helicopter going to have the most efficient path. So remember, it's not ax plus ay, just the way that they have it. You know, it might look like it's gonna be oh, let me just add up these.
The size?
Right. It looks like, oh, let me just add up the sides, but then we realized, no, that's not vector. You know, we have to make sure that it's giving us an angle as well. It's not just magnitude, because that would be adding up magnitudes, but gotta add up the directions too. Correct. Yep. If the vector A is known, then its magnitude and its angle are known. So then we gotta figure out what it is. All right, so